Alright, welcome again, ladies and gentlemen. Welcome to another lecture. So in this lecture, we're going to cover the doubly linked lists. Doubly linked lists. So let's write that down. So doubly linked lists. So what is a doubly linked list? Well, a doubly linked list is basically a list, just a simple list. But every list node has both a next pointer and a previous pointer. Okay, and of course a value. So that's a pointer, and that's a pointer, 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 pointer. Okay, and every next pointer points to the node to the next, to the right of that node. And the previous node points to the previous list node. And of course, the previous of the first list node is null, and the next of the last list node is null. And we have our list structure. Instead of having head and size, it'll have three properties now. The first one is head, the second one is tail, and of course some metadata such as size. The head is just a pointer that points to the very first node, and the tail is a pointer that points to the very last node. Basically, that's the only difference, okay, between the simple and doubly linked lists. So for a simply linked list, every node points to the next one. So every node has a value and a pointer that points to the next node. Here, every node has a value and two pointers. The first one points to the next node, and the second one points to the previous node. So basically what we're going to do here, we're going to take the implementation of the simply linked list and change it, customize it in a way to become a doubly linked list. Okay, so here we have a singly linked list implementation, and we're going to add the required stuff to make a doubly linked list. So here we have int value and a pointer called next, and we're going to add another pointer called previous. So that's a pointer, that's a pointer called previous. And of course the list structure will also have a pointer that points to a list node called tail. And to initialize the list, of course, we're going to create a new list, and the head of the list takes null, and also the tail will take null as well. So both the head and the tail will equal null. And the size, of course, starts at 0, and then we're going to return the list L. Checking whether the list is empty or not remains the same. So we're just going to compare the size property of the list, whether it equals 0 or not. True if it is, false if it is not. Now to push an element to the left of the list, to the front of the list, basically we're going to keep it the same way but with minor differences. So to add an element to the list, first of all, we're going to check whether the list is empty or not. Okay? So let's get back here. So let's say we have a newly created list here. So this is a list. It has a head and a tail and size. Okay? Now if the list is empty, if the list were just created, then of course both the head and the tail will point to null. Okay? Now, if we want to create an element, then if the list is empty, Then we're just gonna create our list node and fill the values there. And its previous is null and its next is null. And the head of the list will point to that newly created node. And of course, the tail will also point to that newly created node. Okay? So that's, well, that's pointing to the node, of course. That's pointing to the node. Now, what if the list is not empty? If the list is not empty, just like this case, for example, we're going to create our new node. And depending on whether we want to put it to the left or to the right, we're going to change the pointers here. So for example, this newly created node, let's say we're going to add it to the back of the list, or let's add it to the front of the list. Okay, so let's create a new node here. It has the number 9. So the newly created node next becomes the head value, okay, because it points to the same node that the head of the list is pointing at. So the first instruction would be our newly created node, so list node next will be equals to the list head. Okay? And the previous of that node will be null. So list node previous would become null. Now the last thing we're going to have to do is to make the head of the list points to that newly created node. So let's do that. So the head will point to that newly created node. So ln, or the list head, takes ln, that newly created node, that list node. Okay, so let's code that. So here back to code blocks, we're going to, as we mentioned, create the new node and then assign its value. And we said that both its next and its previous will initially take null. And then if the list is empty, then all we're going to do is basically we're going to connect that node to the head of the list as well as the tail of the list. So both the head and the tail takes that newly created node. And of course, after making that connection, we're going to have to return because we have nothing else to do, okay? So let's increment the size of the list, and then let's return. Otherwise, if the list is not empty, then since we're trying to add to the left of the list, then we're going to have to follow the instructions that we've written on the whiteboard here. So we said that the ln next takes the head. So ln next takes the head, that's cool. And then we said the previous takes null. So we don't have to change the previous since we already initialized both of them, both the next and the previous is null, and we changed only the next. So the previous is null, okay? And finally, the list head becomes that newly created node. So head becomes ln, and then the size gets incremented. So basically, this is the only required change that we're going to have to add to the push front list in order to make it work for doubly linked lists. Cool. Now, if we want to push back to the list, then unlike before, whenever we wanted to add to the back of the list, then we created a pointer that would iterate through the entire list until it gets to null. Then after that, it knows that it reached the end of the list, so it's going to place the newly created node there. But for the linked list, the doubly linked list, we don't have to do that anymore because we already know the tail of the list. We know where the list ends. So we're just going to add another node, and then we're going to connect that node to the list that we have, and then we're going to update the tail, and we're just going to quit. So that's order 1 complexity. So let's do that. So let's clear this. Cool. Now let's say we want to add the number 3. So we're going to create, of course, the node, and that's what we did. And then we're going to connect the node. So the previous of that list node, the newly created node, its previous is going to be the tail of the list, okay? The node that the tail is pointing at. So the previous of the list node will be equals to the head of the list. So that's the first instruction. Now the second instruction is to make the node of the second instruction is to make the node that the tail is currently pointing at, to make its next our newly created node. So we want to connect this node here to the newly created node. So we know that the list node, this list node here, the tail of the list is pointing at it. So we're going to say list tail next. So we're talking about this pointer here. So the next there would equal to the newly created node. Okay? And the last thing that we have to do is basically to update the tail of our list. So this pointer here becomes pointing to our newly created node. Okay? So let's do that. So the list tail becomes the list node that we've created. All right, so let's do that. And of course, we're going to have to remember that if the list is empty, then we're going to, whether it's pushing from the front or from the back, if the list is empty, we're going to do the same thing. We're just going to connect both the head and the tail to that newly created node. So let's do that. So we're going to create the node and then assign its value, and then both its next and previous, both of them would take null. And then we're not going to need this pointer which will iterate through the list. We're not going to need this iteration. So all of this, we don't need it. All we have to do is to check whether the list is empty or not. So if the list is empty, then basically we're going to do what we did for the push front. Okay, so let's copy paste that. Cool, so both head and tail takes the address of that newly created node, and then we increment the number of nodes that we have in the list, and then we return. Okay, if the list is not empty, however, we're going to have to follow the 3 instructions that we mentioned in the whiteboard here. So we said the previous of that node, of the created node, becomes what the tail is pointing at. So this is the tail, not the head, of course. So this is the tail. So ln previous takes the tail of the list. And then the element pointed by tail, its next becomes our newly created node. And then finally, we're going to have to update our tail. So the tail becomes our newly created node. And of course, we're going to have to increment the size. And here, of course, we're going to have, we forgot to add an instruction which will connect the element to its previous one, to its ln here, previously. So if we wanted to add this element here, then before changing the head to point to that newly created node, the node that was pointed by the head, its previous must be the newly created node. So here we have to do that here. So L head previous takes ln. So that instead of this null thing here is going to point to our newly created node, and then of course we change the head to the newly created node. Cool. So that's the basic code that we have to write in order to get a working doubly linked list implementation efficiently. So let's test that, okay? Let's see if that works. So we're going to push back to the list. I'm going to change this to front because we didn't change the back yet, so push front. Well, we wrote the back, but let's test them one by one. In order to make sure to see whether this works or not, basically I'm going to make changes, the required changes for the pop function.